Okay, so today, I'll pass that back, please. We're going to use logarithms. We're going to use logarithms to solve problems. So Common Core is F for functions, IF for interpreting functions, E, and it is using exponential and logarithmic functions to solve problems. And it is St. Patrick's Day, 1717. Look at that. Okay, so let's look at example 1, huh? So first of all, the hydrogen ion concentration. So that's our H plus, all right, is equal to 3.16 times 10 to the negative 8, okay? So it's like a solution. That means we've got a few of these hydrogen ions floating around in water. Not very many, but in terms of a solution of water, percentage-wise, that's how we get this small number, okay? It's like a solution. So find the pH. So we go to our formulas, okay? So let's check our formulas out. We're going to use our pH formula, which is this one right here. Okay, so we're going to go, all right. We're going to see our pH is equal to our negative log of our H plus. And our H plus is our hydrogen ion concentration. So all we're going to do is put this number right there. That's all we're going to do. We're going to use our formula to find the pH. It's the negative log of our hydrogen ion concentration, which is 3.16 times 10 to the negative 8. So okay, pH is equal to negative log of our 3.16 times 10 to the negative 8. Use our calculator, obviously base 10, right? Obviously base 10, which means we can use our calculator. That's what I want to do. So I'm just going to go negative log of 3.16 times 10 to the negative 8, okay? Right, about 7.5. So the pH of this is about 7.5. So it's not acidic at all. It's slightly basic. Slightly basic. If it's 7 is exactly like purified water, anything bigger than 7 is a base, anything smaller than 7 is an acid, okay? Alright, next example, right? So the most acidic rainfall ever recorded in Scotland in 1974 with a pH of 2.4. Now you've heard of acid rain. You guys ever heard of acid rain? It's not very good. It's kind of crazy, but at one point in time Canada was really mad at Detroit because, you know, Detroit was pumping off all sorts of horrible chemicals. And then literally the stone foundations of some of the really beautiful old buildings were starting to corrode because of our acid rain. So they wanted the U.S. to clean up their pollution problems. So anyway, we got a 2.4 pH. So let's look at our formula. We got our pH is equal to our negative log of our hydrogen concentration, right? So we'll go 2.4 is equal to negative log of our hydrogen concentration. Let's find out what we got. So how do I solve for this? Well, we have a hidden base, right? We have a hidden base of 10. Everybody agree with that? So let's put our little 10 in there. Let's put our little 10. So we got a hidden base of 10. And then I'm going to rewrite it in exponential form. I'll go 10 to the 2.4. I'll go 10 to the 2.4 equals, well, our hydrogen, our negative hydrogen concentration, right? So the negative's there. But if I bring the negative over, well, of our hydrogen concentration, let's do that. 2 to the 10, 10. Well, hold on. I got to take it to the, I am making a mistake. I know, hard to believe, huh? I got to bring in the negative over with it. The negative comes up. You with me on that? To negative 1 power. There we go. You with me on that? Bring the negative 1 up. So I bring the negative with the 2.4. So we'll go 10 to the negative 2.4, and we get about 0.0039 is our hydrogen concentration, okay? Or the book likes this is about 4 times 10 to about the negative 3, okay? So I round that up to 4. 0.004. Then I go 1, 2, 3, right? So we put it in scientific notation. It's about 4 times 10 to the negative 3. Am I doing okay? I'm not confusing you yet?
Can we leave it in the decimal form?
You can leave it in this form, yeah. Say it again, what? Elijah, go ahead. No, I don't want you to be confused, right?
It's just for how you got the 4 times 10 to the negative 3.
Oh, great question. Here? So that's about 4. You agree, 3.9? It's about 4. Let me change it to that. So scientific notation, right? Remember that? So I moved the decimal 1, 2, 3 places. I went back 3 places. So it's just 4 times 10 to the negative 3. That's just scientific notation. Okay, good. Okay, number 2, magnitude. So the magnitude of an earthquake that has an intensity of 3.75. Let's find the magnitude. So the magnitude, so we go to our little formula, magnitude formula. Let's see, we've got this little thing here. Our magnitude. Here's our formula, but we said that S was 10 to the negative 4. So we really wrote it like this. We can rewrite it as magnitude is equal to the log of 10 to the 4th times the intensity, okay? So the intensity is the seismograph. So this thing's going like that, right? And it's going back and forth between 3.75 and negative 3.75. And that's how they measure the intensity, okay? So the machine goes back and forth, and you get 3.75 intensity. So what's the magnitude? Well, to get the magnitude, we'll just plug it in. It's actually pretty easy. We're going to put our 3.75 right there. So M equals the log of 10 to the 4th times 3.75. Let's use our calculator and see what we get, all right? So clear log of 10 to the 4th times 3.75, and I can answer about 4.57. 4.57 is the magnitude of that earthquake. Okay, and that's not a big earthquake, but you know, we'd feel it. We would definitely feel it. Okay.
Well, how big were the ones that had 11 earthquakes?
They were around that 4 or 5. They weren't huge, you know. I was in Japan one year when we had like a 7.5, and it was freaky. Literally, we were in a tower, apartment tower, right? And true story, middle of the night, my bed went hop, 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 hop across the floor. Hop, 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 hop across the floor. And I jumped up and I screamed. I mean, you know, you're dead sleep, and all of a sudden your bed is going. And then we're thinking, if this tower apartment's going like this, who knows, right? Well, it stopped before, you know, it lasted for about 10 seconds, and it was scary, right? And then it stopped, right? It was crazy. Yeah. Cried like a baby. No, I screamed like a baby, really, it did. Okay, another one. So, another quake had a magnitude 5.1 on their scale. Find the intensity of that quake. So we do it just the opposite. We have, this is the magnitude, right? So we're going to go magnitude is equal to log of 10 to the 4th times the intensity. So what we're really going to do is try and find out how big it went back and forth on the scale, right? How many centimeters? So if we know it was a 5.1, 10 to the 4th times the intensity, okay? Hidden base, right? Hidden base of 10. So let's go 10 to the 5.1. Let's start there. 10 to the 5.1. So we go 10 to the 5.1 equals a 10 to the 4th times I, right? Let's divide, right? So let's go 10 to the 5.1 divided by 10. Whoops, that's a bad looking. Do it again. 10 to the 5.1 divided by a 10 to the 4th. And let's figure out what that is, okay? Let's clear and go 10 to the 5.1 divided by 10 to the 4th. And I get about a 12.6, 12.58 or 12.6. And that's in terms of centimeters. So that means this thing is going back and forth as high as 12.6 centimeters, okay? That's the intensity, okay?
You know how big the one's fan was?
They, actually in your book, they talk about the biggest they ever had, which I think 8.9 they say. If you read it in the book, it talks about the biggest they've ever measured was, I think it was 8.9.
8.3.
No, I see 8.9 on the Richter scale. And this correlation is intensity of 80, wow, 800 million. This way? Yeah. Yeah. So big that it probably the Richter scale is just flapping all over the place, okay?
Oh, it said
Yeah.
9.5 in 1960.
Really? 9.5? What did it do? What was the damage it did? I can imagine, yeah. Yeah. So yeah, that ring of fire, right? That Pacific plate's always going this way, and the North Atlantic plate's going this way. And turn that page. So, in 1906, San Francisco's earthquake measured to be 8.3. And there's a little bit of history, but when the San Francisco, a little history, you know, I'm not Mr. Allen, I know, but a little history, when the San Francisco earthquake hit, San Francisco burned down. You guys remember that history? When this earthquake hit, San Francisco burned down. And then San Francisco had another big fire after that, too, but it was a fire. So, same year, there's an earthquake in Columbia that's 4 times as intense, okay? So find the magnitude of the Columbia. Now 4 times is not necessarily just multiplied by 4, because it's like a x to the 4th power. So here's what we're going to do, okay? We're going to set up our magnitude is equal to the log of 4 times our intensity over our S, okay? And we know the S is going to be times 10 to the negative 4. So let me rewrite this. So our magnitude now is log of our 4 times our 10 to the 4th times our intensity, okay? How am I doing? I'll back up, okay? So we want 4 times the intensity, okay? So I multiplied it by 4, okay? We know that S is times 10 to the 4th, right? So the intensity was 8.3, so I can put my 8.3 into there, right? So I'm going to go, the magnitude is going to be the log of 4 times 10 to the 4th times my 8.3. And let's see what we get. Let's use my calculator. So go log of 4 times 10 to the 4th power times 8.3. We get about 5.52 for the magnitude. They got a different answer. They got a different answer. They shouldn't have gotten a different answer. I'll check that one out. I will check that out. They got a different answer than I got. Okay. Example 4. Let's go to 4 and I'll see what mistake I made. Decibel level of a jet. Okay, so decibel, let's do that one. Decibel level, there it is. So let's go. B is equal to our 10 log of 10 to the 12th times its intensity. Okay, that's our formula. And we've got that the intensity was 100 W per meter squared, which has got to stand for something, huh? Not watts, I'm sure it is. It is watts per square meter. Huh, okay, it is watts. What do you know? So, let's put our 100 in for the intensity, right? I'll go B is equal to 10 log of 10 to the 12th times 100. And see what kind of an answer we get. Right, calculator. 10 log of 10 to the 12th times 100. And I get about 140 decibels. They go dBs for decibels, but they like capital B for decibel, okay? That's not super loud, right? Well, yeah, jet taking off is pretty loud, okay? Okay, how about a motorcycle? So if a jet's 100, what about a motorcycle, okay? So find the intensity, okay? So just work it backwards. We'll go 90 is equal to our 10 log of 10 to the 12th times I. We're going to solve for I, okay? Yeah, you guys agree? Divide by 10. Divide by 10, I get 9 equals log of 10 to the 12th times I, right? We can take then, let's just do this. Well, the book does it a different way. We can take this to 10 to the 9, right? We can go 10 to the 9 power equals 10 to the 12th power times I. How am I doing? Does that make sense? Divide, 10 to the 12th divided by 10 to the 12th makes 10 to the 10 to the negative 3. 10 to the negative 3. Which is about a point.
How did you get 10 to the 9?
Oh, what's my hidden number here? Yeah. And then I just subtract x minus to get 10 to the negative 3, and that's the intensity. We know 10 to the negative 12 is just a whisper, okay? 10 to the negative 12 is just a whisper, so 10 to the negative 3 would be like probably me speaking, so quiet. Okay, so it's not that many problems. It's 5 problems. They deal with all of these different formulas, which isn't too bad. I don't want to give you a lot. It is Friday, so anyway.